So this is a function 1 over x squared minus 2x minus 3. Notice that in this formula, there is division taking place. And there is a variable in the denominator. So this is where we do have to consider potential limitations to the domain that are caused by that division by the variable. You can never have division by 0, so what we're looking for is we need the denominator to not be 0. So I'll typically write that like this, that x squared minus 2x minus 3 must not be 0. And then I'll look at that statement and see if I can determine the domain just from that statement. One of the things we can do is factor the left-hand side. So this x squared minus 2x minus 3 can be broken up into two binomials where we start with an x and an x. So together, if they were to be multiplied, they would make x squared. And then we just need some number here and some number here that when they get multiplied, they will multiply to the negative 3. So some things that multiply to negative 3 could be 1 and negative 3, or else negative 1 and 3. Those are the only possibilities. We're looking for the combination that would also add to the middle term of negative 2. So that's clearly this combination here. This is the one we need that meets both criteria of multiplying to negative 3 and adding to negative 2. So it's going to be x plus 1 and x plus a negative 3. So I'll rewrite this now. And now it's completely factored. We need for the product of x plus 1 times x minus 3 to not be 0. According to a thing called the zero factor law, the only way that two things could be multiplied to make 0 is if at least one of them is 0. So it must be that either x plus 1 is 0, or x minus 3 is 0, or perhaps both of them are 0. Usually that's how we write the zero factor law, but I'm keeping in mind here that I need this x plus 1 to not be 0, and I need the x minus 3 to not be 0 too. Now I'll solve these each individually with algebra, and we see that x cannot be negative 1. Also, x cannot be 3. This is an algebra way of determining what elements are banned from being part of the domain. These two elements cannot be part of the domain of this function because they would cause division by 0. Let's see if that's true. Okay, so this was our function. I'm going to now plug in f of negative 1 to prove that negative 1 cannot be part of the domain. So we get 1 over 1 plus 2 minus 3 if we plug in negative 1, and that gives us 1 over 0, which is undefined. And so a negative 1 cannot be in the domain. We could also try this for 3. If we plug in a 3 here, we get 1 over 9 minus 6 minus 3, which is 1 over 0, and that's undefined. So clearly, negative 1 and 3 are not part of the domain. So how do we write the domain then? Well, if it wasn't for those two problems, the domain would be all real numbers. So anything from negative infinity to infinity, if not for the two values which cause problems. So we have to exclude those values from the domain. The way we write that then is, you could say x cannot be -1 and x cannot be 3, but x could be anything else. One way to write that is with interval notation. The problems are occurring here and here. So a drawing of the domain would show that there's an open dot at -1 and 3, and every other number is part of the domain, so it should be shaded in. That's a drawing of the domain. I'll now put it into interval notation with these parentheses. So in order to describe this section of the domain, I'll write that it starts at -infinity and it ends at -1. For this section of the domain, I'll have it start at -1 and go to 3. And then for the final section, we'll say that that section goes from 3 to infinity. At the end, you just have to put a union between all the different parts. Union means we'll join together one or more intervals in order to describe the complete domain.